Talk to you guys later. Okay.
Okay. So I'm gonna share my screen real quick. So do you have any question about the homework for last week?
No,
No? Oh,
no.
okay. So, I'm gonna share my screen. Sharing screen, share. Okay, can you see it now?
Yeah.
So let me see where we left off last week. Um, 120, 120. So we are almost done with the first two chapters, and maybe today, if we finish this chapter two, you can I'll give you like you can finish the chapter two test, like to test your like how like your knowledge for the first two chapters.
Mm.
So we were somewhere around here. Okay, but I think we're done with this. Okay, so we can start chapter three now. So in chapter three, it's talking about parallel and perpendicular. Do you know parallel and perpendicular? Like those
Yeah.
two words, you know them, right? So like
Yeah.
parallel is like two like parallel lines that they're like have the same slope, but they never intersect each other, right?
Yeah.
And perpendicular is like create a 90-degree angles, right? So prerequisite skills. Adjacent angles share common what? Do you still remember? Adjacent angles share a common.
Mm. No, I can't remember. So,
So remember, what is adjacent angle?
uh,
So here option
that's one.
is
Yeah.
that an adjacent angle,
Mm. Yeah.
right? They're adjacent. So what do they share?
They share the same X.
X. Share, just share the same side. They just share
Oh,
one
same
side,
side.
right?
Yeah. Yeah.
That's how it works. I remember that. And two angles are if the sum of their measure is 180.
Two. Oh, two angles are
What angles if the sum of their measures is 180?
90 degrees.
Like no. It's asking you
Oh,
like there's a name for this. Like if two angles add up into 180, what how do you call them? There's a name for it.
we did this a couple weeks
It
ago.
starts with S. Letter
Mm,
S. It starts with S.
oh, I have in my notes.
Okay. Check your notes.
Mm, oh, supplementary.
Yep, it is supplementary. And what is a complementary angle? What is complementary angles?
They add to 90.
Yes, exactly. Remember that. So let's see. Draw and interpret lines. I mean those let's try two like this. Just practice with it. So A, like line JK, which is right here,
Yep.
and line NR, which is right here. Will they intersect in space?
No.
No, right? So because this is up there, right? It's a
Yeah.
and this is down here. How about B, line QR
Mm,
and line MR?
yeah.
Yeah, they do intersect. How about this one? C.
Mm. Oh, oh, yes.
Okay. Yep. And how about D?
No.
Yep. They do not intersect. Okay. So a new word, skew lines. Have you heard of skew lines before?
No.
Okay, so let's do it. Two lines that do not intersect are either parallel or skew lines. Remember that. Two lines that do not intersect are either parallels or skew lines. Two lines are parallel lines if they do not intersect or are coplanar. So you know parallel lines, right? But two
Yeah.
lines are skew lines if they do not intersect and are not coplanar. Remember that. And two lines there that do not intersect are parallel lines, right?
Yeah.
So so you have to remember the definition for skew lines. So they do not intersect and they are not coplanar. But for parallel lines, they do not intersect and are coplanar. So the difference between them is like if they are coplanar or not.
Okay.
See right here, line LM and line M and line N are parallel lines, right? Because see, they
Yeah.
do not intersect and they're coplanar. And M and K, which is over here, are skew lines, right? They do not intersect, but they are not on the same plane.
Yeah.
And plane T and plane U are parallel planes, right? They do not intersect and they're like on the same, yeah.
Yeah.
And line K and N are intersecting lines. So, okay. So after definition, distinguishing is part of the thing. To think of each segment in the figure as part of the line which appears. Description. Let's try A. Lines parallel to CD to line CDs are containing point A. So let's find CD right here, line CD, right? This is line
Yeah.
CD. And it wants to find a line or lines that parallel to CD and also containing point A, which is right here,
Yeah.
right? So which one fits the definition for it, the description for it?
Uh, they're parallel. Okay. Same plane. A B.
Yep, AB, that's correct. So, and how about B?
Skew line. A H.
Yep, and there's more than one.
A G.
Yep, exactly. How about C?
Continue. A D.
Yep, it is AD. How about D? Question D.
Plane as parallel to plane EFG and containing plane A. Parallel EFG parallel. That means BAD.
BAD. Yep, plain BAD. That's correct. So, okay, let's go. Um, okay, two postulates over here. Parallel postulates. If there's a line and a point not on the line, not on the line, then there exactly one line go through the point parallel to the given line. You uh you should write it down, write the two postulates down because
Yeah,
it's
I took a picture of them.
okay, that's fine. Okay,
Yeah.
but just you study them like later.
Okay.
And there, if there's a line and a point not on the line, and there's exactly one line go through the point perpendicular to the given line, there's exactly one line go through the perpendicular. Okay, so just basically saying that if there's a point not on like the given line and they're parallel, so then they have to be like parallel to it, right?
Yeah.
So, or perpendicular to it. So, um, I don't. Let's see. I think those are. I don't think we need to do those. Okay, this is pretty important. This part. So, a transversal is a line that intersect. Um, that intersect two or more coplanar lines at different points. So it is a line that intersects two or more coplanar lines at a different points. So like this one, see, like
Yeah.
line T, it intersects with two lines, right?
Yeah.
So you call line T a transversal. So two angles are corresponding angles if they have corresponding position. For example, see, look here. You know, if a line intersects another line, they create four angles, right?
Yeah.
And so is this one, right? So totally we have 8 angles over here, right? In this
Yeah.
graph. And remember, if there's a if like angle 2 over here and angle 6 over here, they share the same position, right? They are all like upper right angles, right?
Yeah.
Like on the upper right hand, like right side, right? So is this one. So you call that angles, like the pair of these angles, corresponding angles. So you call them corresponding angles. They're like a pair.
Yeah.
And they're also alternative interior angles if they lie between the two lines on the opposite side of the transversal. See, they're opposite and they're also inside the two lines, right? They're inside
Yeah.
here. Like this is outside, right? The bottom and the part, then the upper part, they're out, that's outside. And inside, you call them interior angles. And they're alternative, they're alternate, right? They're
Yeah.
like on different sides. And this is alternate exterior angles, right? If they lie outside the two lines and on the opposite sides of the transversal. And here is the consecutive interior angles if they lie between the two lines and on the same side of the transversal. See? So the main difference between the interior and the exterior consecutive, look. So like for alternate interior, they're on the opposite sides, but for the consecutive interior, they're on the same side.
Okay.
Just remember this for definitions because later you're gonna use a lot of this to prove a problem. Like they're not only gonna ask you like the measurement of an angle. They're also gonna like ask you to show them how that is right. So identify all pairs. Just identify. Just do one. Just do one. Identify one pair. That's fine. That will be fine. Let's do question A first.
Okay.
What is a just you just have to identify one pair of angles that is corresponding.
That's corresponding.
Yeah, in this
Okay.
graph. In this graph. In this graph on the right side.
5 and 1. Oh,
Yep.
just the. Yeah. Okay.
So 5 and 1. Here's so they're on the same side, right?
Yeah.
And on the same position. How about alternate interior?
2 and 7.
Yep, because you have to find the inside of two lines, right? This is like the interior side, like interior part of two lines because they're between two lines, right? So you just have to find the alternate interior angles. How about alternate exterior?
1 and 8.
Yep. So on the different sides and also on the outside. How about consecutive interior?
4 and 7.
Yep, exactly. Okay. Let's do this one. Classify this pair. Question 3.
Okay.
What kind of pair? What's the kind?
Corresponding.
Yep. How about 4?
Alternate exterior.
Yep. How about 5?
Alternate interior.
Yep. You got it. So I think you get all of this. We can move on to the next part. Yeah, find the measurement. Those are pretty. Okay. Use parallel lines and transversals. Okay. Okay, here's the first postulate. You have to just take a picture or write it down, this one, for this postulate. If
Okay.
two parallel lines are cut by a transversal and the pairs of corresponding angles are congruent. So remember that, see?
Yeah.
There are two parallel lines, right? Line P and Q. And there's a transversal that cut through them, right? And which creates 4 angles. So the corresponding angles, they will be congruent. Got it?
Yeah.
So they have this, so angle 2 and angle 6, they are equal to each other.
Okay.
Because, but remember, but remember, two lines have to be, they have to be parallel in order for this postulate to be true. If line P and Q, if they are not parallel, then that will not be true. Then they are not congruent. Remember that they have to be parallel in order for this postulate to be true.
Okay.
And also here, there's a lot of theorems over here. See, alternate interior angles theorem. See, if two lines, remember, in this case, they all have to be, these two lines, line P and Q, they all have to parallel to each other. And if they're also cut by a transversal, the alternate interior angles, they are congruent, they are equal to each other. The measurement of the alternate interior angles, they are equal to each other. And for alternate exterior angles, they are also equal to each other. They are congruent. And for alternate and for consecutive interior, they are supplementary. That's the main difference here. That's the one you have to pay attention to.
Okay.
Because see, for this two and also the corresponding one up over there, they are all congruent to each other, right? But for this
Yep.
one, they're supplementary. They add up to 180, right?
Yeah.
But that just take a picture of it and write it down in your notes later because
Okay.
you're gonna use them a lot, like throughout geometry. This is really important.
Okay.
Okay, let's try to do this one. Find the value of x. Use the theorems that we just learned.
Okay.
Here are the theorems you can look at.
Okay. Find the value of x.
Do you get it?
No, I'm kind of confused.
Like which part?
Trying to identify. Trying to find the value of x.
But which part are you stuck with? Like,
Finding the value like of x. Cause that's the first step, right? Or no?
but like you have to like identify the relationship between them, right? Otherwise,
Yeah.
you can't really set up
Oh yeah,
like.
the relationship. That's what I'm kind of confused about.
So remember, this is the angle. Here's the angle 4, right?
Yeah.
But it's not like the measurement of angle 4. It's not given to us, right?
Yeah.
But remember, there's also like a postulates that we know before, right?
Oh, they equal 180.
Are you sure? Look, they are the opposite angles.
Oh no. Opposite.
What's the
Oh,
relationship between 115 and 4 and angle 4?
they're corresponding angles.
Are you sure 115 and angle 4 are they corresponding?
Oh no.
The corresponding angles. Look, they're on they're on the same position, right?
Yep.
But it's not saying they are opposite. They just share the same position, right? So
Yeah.
what's the relationship between angle 4 and 115?
They're alternate.
No. It's not. We are not using theorems from here. We are not using any theorems from here. There's a there's we are now using a theorem like a postulate that we talked about before in chapter 1 and 2.
Yeah, I'm stuck on this one.
Okay, but then how about we can use another way to do this? So we know this is 115, right?
Yeah.
We know this is 115. Then do you know the measurement of this angle?
Oh, so equal E. S, because that equals to 180. So.
So we know this is a straight line, right?
Yep.
And what do they add up into? If this, like, if we say there's a, like, if this angle,
65.
yup, so this is 65, right?
Yeah.
And what's the relationship between this angle and x plus 5?
They're corresponding.
Then what do you do? If they're corresponding, then what do you do right now?
And then you.
What's like corresponding? What's the relationship for corresponding angles?
They have the same angle.
They have the same measurement, right?
Measurement. Yeah.
So what do you do right now to solve for x?
X plus 5 is equal to. X plus 5 is equal to 65.
Yep. So what's x?
Uh,
What's the value for x?
60.
Yep, 60. Okay, so that's how you solve it. But remember, there's a theorem that if two lines intersect, right? And so they create 4 angles, right?
Yeah.
They create 4 angles. The opposite angles, which is like if we say this angle and this angle, they are always congruent.
Okay.
See, we talked about this, right? Look, like any angles, if we like this, if that creates 4 angles, right? This angle and this one, they're always congruent to each other. They're equal.
Oh.
And this one and this one, these two, the opposite angles, they are
Equal.
congruent.
Yeah.
Right?
Yeah.
You have to remember that we've talked about this like You see now, like you are using the knowledge from chapter 1 and 2 into chapter 3, right?
Yeah.
So all this knowledge add up to each other, and eventually, like when you like finish geometry, like you will be using all of like all the theorems that you know, and to prove a like a problem,
Okay.
right? That's how they do it. See?
Yeah. Okay, that makes sense now.
Substitute 115 for measurement of 4, right?
Yeah.
Okay. Um, let's try this one.
Okay.
Number 1. If angle 1 is 105, and it's asking you to find measurement of angle 4, 5, and 8. And also remember, tell which postulates or theorems you're using.
Okay.
So what's measurement for 4? For angle 4?
So 75 degrees.
Yup. And 5, what's the measurement for angle 5?
105.
And 8?
75 degrees.
Okay. Let's do this one. If measurement of angle 3 is 68,
Mm.
and angle 8 is 2x plus 4, what's the value of x?
Okay.
Oh, if you do not know how to solve it, try to write it
54.
down.
X equal to 54.
54.
Wait.
Um, let's see.
Wait, no, that's wrong. Because it's equal to 108. Oh, that's not hard.
54. It is 54.
Oh, it
Yep.
is? Oh,
It is.
never mind.
It's right. So you have to add them up together, right, into 180.
Yeah.
Those are not hard. See, like those, what postulates or theorem justify the statement. See, it's asking you just to state the theorems.
Yeah.
So you have to like memorize the name. You really have to memorize the name. This one might bit. Let's see. Let's try this one. 35. It's a challenge. I don't know if you can do this. Let's see. I'm gonna. Yep, you can solve it. It is possible. It is. Well, let's do this together. I'm gonna write it down. I'll draw it down. Let's do this together. So here's the angles, right? So that's fine. That doesn't matter. Just look see just see it as a straight line, and as they're parallel. Remember, this is the sign for parallel lines. Remember,
Yeah.
if you draw like a little angles over here, it means they're parallel to each other. So here's 60, right?
Yeah.
And here's 40. And this is what? 2x plus y, 2x plus y, and 2x minus y, 2x minus y. So from now, do you find any relationship between them?
Yeah. They're
Like
they're corresponding.
which one? Which one to which?
2x minus y and 2x plus y.
Are they corresponding?
No.
See, there's because you know there are three lines they're parallel to each other, right?
Yeah.
So if we want to solve this question, let's make the line longer. Like it doesn't hurt that, right? Because
Yeah.
the angle is still angles, but it's better for us to see if they're like what's the relationship between them. And here we can see draw it longer, the transversal. What do you find over here? What's the relationship between these two ones?
They both share a that's a 60-degree angle.
2x plus y and 60 and 60, 60. What's the relationship between this angle and this one?
Oh, they share the same we did it in the beginning. They share the same
So
That's what
I
an
mean,
A is.
okay. So if you do not look at the bottom top part of
Yeah.
the graph, so it will
Yeah.
be just like two lines parallel to each other and a transversal, right?
Yeah, that's what I meant to say.
And here's the angle, and here's the other angle, right? What do you call
Yeah.
them?
Oh, the nine transfers.
We just learned that what
Yeah,
there's
we just talked about it. It was the beginning of the A. Adjacent. Right? Is it?
no, that's like about that's the other one
Oh,
that we're talking using one of the theorems over here. Remember? It might
yeah.
not be on here. Like the theorems might not be. See, what's this one?
Consecutive interior angles theorem.
Right. So what does it tell you over here?
These interior angles are equal.
Are they? Are they equal?
No, they're
See, you have to remember the definition for it. So, see, remember, all you have to do is to just to remember that this is like the one of the This is like the only special theorems in all of the theorems that we just learned, like in all this, like this postulates over here and these three theorems. This is the only one that says they are supplementary.
Oh,
See, the others are all congruent to each other, but this is the only one that says they are supplementary. But we can prove it. Let's prove it right now. So let's say if I say this is X, we don't really have to know the measurement. We just have to prove it, right? I'm just gonna prove it with you. So I'm not using a new page. Here, two lines congruent, parallel to each other, a transversal cuts through it. Here's the angle over here, right? Here's an angle over here. If we call this angle Y and angle X, right?
yeah.
What do you know about this measurement over here?
It's congruent to angle X.
It is X, right?
Yeah.
It is also angle X, right? What about this one?
It's also angle Y.
Angle Y. Oh, really? Is this
Oh,
angle Y?
no. Oh, it's angle XX.
It can also be angle X, right? See?
Yeah.
What do they add up to?
180.
See? That's how you prove it, right?
Yeah.
That's exactly how you prove it, because if we know the measurement between these two lines are congruent, then we can know they add up to 180. They're complementary. They're supplementary, I mean, right?
Okay. Yeah.
So you know this. So when you know this two add up into 180, I'm not used to text. It's better. So we can set up the equation for 2x minus y, which is the measurement for this angle, plus 60, right?
Yep.
Equals 180, right?
180. Yeah.
And remember, look here. But what do we have here? We have two variables, right? We have
Yep.
x and y. So we cannot solve for that, right?
Yep.
But look, but you've learned about the system of equations, right? Which is like two equations set together, and then you can solve for it. So then what's the relationship under here?
They add up. They're equal to 180.
Okay, so what's a theorem called? What's the name for the theorem?
Oh, you just said it. I can't remember the word though. The consecutive interior angle theorem.
Consecutive interior angle theorem. Yep. So you know they also add up into 180, right? 2x
Yep.
plus y plus 40 adds up into 180, right?
Yep.
See, now we have two equations over here. Let me put it up. We have two equations over here. What's like a theorem that you've learned before? Have you learned any like theorems for a system of equation back in algebra 1?
Yeah.
What are the ways for you to solve the system equation?
I can't remember the theorem. I think I remember how to do it.
But yeah, then tell me how to do it.
I think you add both x's, and then you put together both x's, and then
You put together both x's. So 4x, you mean? So 2x plus 2x gets 4x, right?
Yeah.
And then what do you do?
Then you 2x plus 4x. I think it's the top number. Then you add the top number and number at the top. So you add 60.
You add 60?
No.
So if you wanna, so So what's the purpose for setting up a system of equation? We want to, so if you want to solve for a system of equation, you have to cancel at least, you
Oh,
have to
cancel out. Yeah.
eliminate one of the variables, right? Because it has two
Yeah.
variables. So you want to try to eliminate one of them, right? Which
Yeah.
leaves you only one variable, and that's really easy to solve, right?
Yeah.
So what do you, so you want to, so right now, if you want to add the system together, if you want to add two equations together, then you have to add everything together.
Yeah.
But here, see, there's a negative y and there's a positive y. If you add them together, what gives you what?
Nothing. 0.
Nothing, right? Gives you a
Yeah.
0, which so we cancel out y, right?
Yeah.
But remember, but when we cancel out y, we also have to add the rest together. So gives you 100.
100 equals 180.
No,
Oh.
remember,
Oh,
see,
360. 360. Yeah. That's right.
right?
Yeah. 360.
Careful with that. And now you solve for x, right?
Yeah.
Solve for x. Just gonna see x gives you what?
65.
65?
Yeah.
Sure. Try to do it again. It's not 65. Wait, I think it is. Wait a second. Yeah, I think I might did the wrong calculation. Yep, it is 65. My bad.
No
So,
problem.
but here, remember, but we only have the answer for x, right?
Yeah.
So what do you do now? And we want to find y. What do you do now?
You subtract 65 from 180 to find y. Oh, no.
Well, what do you do over here? I mean, you can't just really subtract 180 from 65. That just gives you a number, but it's not really like
Uh,
telling you. You have to
you,
use the system equation over
yeah.
here, right?
Um,
So you put it back, right?
yeah.
So you put the x value back into just any of them, like any of the equation. You can choose the bottom one or the upper one. It doesn't matter. You just have to put it into one, and like just one of the equations. Just put it back. So if I choose to put it in the upper one, I mean the bottom one, see, gives you 130 plus y plus 40 equals 180, right?
Yeah.
So what does y equal to?
Uh, y is equal to 10.
Yup. So if you put x back into the upper equation, it will give you the same answer. But okay, got it now?
Yeah.
And so that it might be a little bit more complicated, but that's how you have to do it. Let's see. Find the value of x. Yep. See. So for this question, it's not asking us to find the measurement for this angle. It's only asking us to find the value of x and y. So we have to double check the question, right?
Yeah.
We won't get the wrong answer. And let's see, we still have some time. Let's do more questions. Those are pretty. Proof lines are parallel. Okay, here. So this is a new postulate in chapter 3.3. Prove lines are parallel. So now we have to prove them to be parallel. But because
Yeah.
before we were told that lines are parallel and we have to prove that angles are congruent, or like, so we have to find the relationship between angles, but now we have to find the relationship between lines. So we are given, so the first postulate, corresponding angles converse. So what does converse mean? It just means like the opposite ways to say it, like just to flip it back, right?
Yeah.
Look, if two lines are cut by a transversal, so the corresponding angles are congruent, then the lines are parallel.
Parallel.
So So we do not, so for now, we do not know if line J and K are parallel or not. We do not know that. So, but we are given that two lines are cut by a transversal, and we are also given that angle 2 and angle 6, which are corresponding angles, that they are congruent to each other. So in the last little units over here, like chapter 3.2, we are in the theorem of corresponding angles. We are told that if two lines are parallel, the corresponding angles are congruent, right? So
Yep.
now we are told that corresponding angles are congruent. So we know that the lines have to be parallel, because that, like, if the lines are parallel, the angles are congruent. If the angles are congruent, the lines are parallel. It's just that simple, right?
Yeah.
So here, the same thing, but they're just converse. See, alternate interior angles. So if two alternate interior angles are congruent, then the lines are parallel. Or the alternate exterior angles are congruent, then the lines are parallel. Or the consecutive and interior angles are supplementary, then the lines are congruent, then the lines are parallel.
Okay.
Just a picture of this postulate. And also, did you take a picture?
Yeah, I took them already.
What about this one?
Yeah.
Okay. Let's try transitive property. Okay, also this one. Take a picture of this one.
Okay.
Transitive property of parallel lines. If two lines are parallel to the same line, then they are parallel to each other. See, if line P is parallel to line Q, and Q is parallel to line R, then P is parallel to line R.
Okay.
It's not really complicated. It's just saying that, like, if the first line is parallel to the second line, and the second line is parallel to the third line, then just the first line is parallel to the third line.
All right.
It's simple, but you have to remember it because you're gonna use it a lot. Okay, here. Question. Actually, I'm gonna. Is it not proven? Would you use? Let's try this one. Is there enough information for you to prove M is parallel to N? And can you prove that line M in a parallel in this question, in question 10?
Yeah.
What's the postulate or the theorem that you use? Check the postulate and theorems.
Alternate interior angle, converse.
Yep, converse, remember, converse, because now it's giving us the angles are congruent, but we have to prove the lines to be parallel. How about this one?
Alternate exterior, converse.
Yep, how about this one?
Mm-hmm. Supplement. Wait. That's not consecutive. Uh, Consecutive exterior, potentially.
Look, read the question again.
Okay. Oh, is there enough? I mean, so. Oh no. So there's not enough information.
See, correct. How about 13? How about 13?
There's supplementary. Oh, sorry. No, that's it should be the same. Oh, corresponding angles converse.
Yup, it is. How about this one?
Okay. Alternate exterior angles. No, that's not. They're not even exterior.
Think about it. Make sure.
Uh, not interior. It's both interior and exterior. So
So look, what's a relationship between them? So they are congruent to each other, right?
yeah, there's supplementary.
Are they
Oh no,
supplementary?
they're congruent. No, they're congruent.
Here,
They're
it just
congruent.
it just tells you that they're congruent. So they can be supplementary. They cannot be
Yeah,
supplementary, right?
yeah,
But look, they're on the same angle, right? They're on the same line, right? I mean, like, look, they're like, see, they're on the same line, right? It creates
yeah,
four angles. It's not on this one, or nor on this one, nor on this one, right? They're on the
yeah.
same like side, on the same part of the gram of the diagram, right?
Yeah.
But look, if you want to prove something, see over here, they always have to be on different lines, right?
Yeah.
But look, this one, but look at this one. They're on the same line.
Yeah.
So it just only it is telling you their relationship, but it's not enough information for you to prove them to be equal, right? Because you're trying to prove line and to be parallel, but but we don't have any information down here for line N. We only know
Oh,
about line M, right? We don't know
yeah.
about this line. There's like nothing to give us. Like there's nothing here.
Okay, that makes sense now.
How about this one?
Oh, they're exterior. Oh, alternate exterior. No, they're not alternate. Wait, they are alternate. Alternate exterior. Angles converse.
Yep, that's. Mm-hmm. So I'm gonna give you some homework. Where
Okay.
we left 165. Let's go back to chapter 2. So for chapter 2, yeah, try to is that test preparations? Let's see, text practice. Those are not. No, I don't want to do. I don't want you to do those. Try to do this one, chapter 2 test.
Okay.
Try to do. There are 21 questions. So try to finish the chapter 2 test. And I mean, I think you know like the theorems, but the other the other homework is just to try to memorize all the theorems that we talked about today. That's it. You don't
Okay.
have to do any homework for chapter 3. You just have to spend a week and try to memorize all these theorems because see, there are 5 in 3.3 and there are other 4 in 3.2, which is over here. This is 4.
Okay.
Just remember those theorems that we just talked about today. Those are really important. You have to memorize all of them.
Okay.
So that's the So that's the homework for this week. Just to complete chapter 2 test, and I will send you the PDF for chapter 3. So okay, so that's it for this week.
Okay.
Okay. Any questions or?
No, I don't have any questions.
Okay, so do you feel comfortable with like where we like with the pace?
Yeah, I
Okay.
just gotta work on memorizing the theorems, and
Yeah, definitely. You have to try to you definitely have to memorize all of this. It's like really important for you to memorize them. It's like you're gonna use it a lot. And also like the one we just talked about, like the opposite angles, like if
Yeah.
two lines intersect and they create four angles, right? And the opposite ones, they're congruent to each other. That's also like the one you have to memorize it. See, like we talked about it in chapter 1 and now we're using it in chapter 4. So and chapter 3, I mean, and we're gonna use it like a lot like later on, like in more like in chapter 5, 6, 7, like in the whole book, like throughout geometry.
Okay.
So okay.